In this video on systems of equations, we're going to be looking at our second non-solution system. This is where we have two parallel planes, and then a third plane intersects those two along two separate lines. Because we don't have all three planes intersecting at the same point or along a line, this is a non-solution system. What's slightly trickier about this system compared to others is that two planes are intersecting along these two lines. And because they intersect along a line, we have infinitely many solutions for two planes, but not all three. So this is a little bit deceptive. It seems like this is an infinite solution system, but actually it's a non-solution system. So please be careful when trying to identify the type of system you're dealing with. In our contextual example, the numbers have been changed slightly to reflect this type of system. So let's put them in the solver. Let's solve it. Of course, we get this error text again, which tells us that we are dealing with a non-unique solution. A solution has been given, so in this case, I'm actually going to put them into our equations to see whether it works. That means I'm going to substitute my prices into each food pack to see if the costs match up. Let's start with food pack A. Food pack A, I'm getting 2 grams of protein at $2 each, so that's $4. The next one will be 2 times -1, that's -2, and then 2 times 1 is 2. Adding those all together gives us $4, not $5. So that means that these prices that were found are actually inconsistent with food pack A. So we're going to have a non-solution system, which means we have no solutions, not infinitely many. As a side note, if this price was changed to $4, then of course it would work, and we would have infinitely many solutions. We can see that here because these two planes here are actually exactly the same. One's just a multiple of the other, including the constant term. So that actually means you're going to have two planes intersecting, which, as we saw before, is when they intersect along a line and give infinitely many solutions. However, the price is actually 5, so it is a non-solution system. Let's proceed with food packs B and C. That will be 1 times 2, 1 times -1, and 1 times 1. Adding those together is $2, so the prices are consistent with food pack B. Lastly, with food pack C, 3 times 2 is 6, 4 times -1 is -4, and 5 times 1 is 5. Adding those together also gives us 7. So the prices are once again consistent with food pack C, but not with food pack A. So still a non-solution system, I'm afraid. Geometrically, we can verify that this is two parallel planes where one plane intersects the other two. So how do we identify something like this? Remember that this is an inconsistent system because the prices don't match between each food pack. Here are our equations. From our previous video, you might notice that the second equation could be multiplied by 2, like this. And then the coefficients for the first two equations match up, but the constant term doesn't. That means that these two planes here are parallel. So those are these two planes, here and here. And so we can't find a solution that matches the two because the price is different. We get the same combination of proteins, carbohydrates, and fats, but at a slightly different price. So of course the prices are inconsistent. However, the green plane intersects the other two, so we can find solutions between these two and these two. In fact, we'll find infinitely many of them. So what you want to look for with something like this is two equations that are very similar to each other, and you might need to multiply to do that. However, the constant term will be different, and then the third equation will be very different to those two. So because of all this, and we have two parallel planes that can't meet at any point or along a line, we have a non-solution system. And that's it. Thanks for watching.